Hello. Check, 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 check. Hello everyone. Today we are going to learn some random topics with Akriti. Hi Akriti, how are you?
Hello, friend. Good to say hi.
I'm also good. So let's start with the topic that we left yesterday. You like that?
Yes, sir.
Okay. Okay. So you can say that it was in geometry, right?
Yes, sir. Geometry A2.
A2 counter examples. Okay, so we can start with the conditionals now.
Okay, sir.
A3 conditional. Is the following conditional true? If a triangle has an angle measuring less than 90 degree, then it is an acute angle. Is this true?
Yeah,
The condition is following it, right?
yeah.
Okay. So it is
Uh,
saying that if is the following condition true? If a triangle has an angle measuring less than 90 degrees, then it is acute. So they are saying a conditional statement can be written as if A then B. A is a hypothesis and B is a conclusion. Counter example is an example in which hypothesis is true but the conclusion is false. If you can find a counter example, and if triangle has an angle measuring less than 90 degrees, then it is acute. The condition is false because every triangle, including the right or the obtuse ones, has an angle measuring less than 90 degree. So that means all the angle has to be less than 90 degree.
so
We
I didn't
miss
understand.
okay. Let me make you understand. So how many kinds of triangles you know on the basis of angle?
Uh, three.
Three. What are the three types of triangle?
Right angle, obtuse angle, and acute angle.
Wonderful. So this is acute angle I am drawing. This one is right angle triangle I am drawing for you. And let me draw one more triangle, which is an obtuse angle triangle. Alright.
Yes, sir.
Now in these three triangles, can you tell me what are the other two angles? Suppose that this angle is acute. What are the other two angles?
They're also acute.
They are also acute. What about in this case? This one is right angle, but what about the other two angles?
Those two are acute.
This is obtuse. What are the other two angles?
Acute.
So if you say that if the angle of a triangle is less than 90 degree, then it is an acute angle triangle. Is this statement true? Because that statement is true only if all the three angles are acute. See, in this also one of the angle is acute, two of the angles are acute. So it is not saying all the angles, it is saying one angle. See the statement. The statement is if a triangle has an angle, what do you understand from an angle?
One angle.
So if one angle is acute, do you really think it can be only acute angle triangle?
No, sir.
It has to be all the angles has to be acute. Understood?
Yes.
Okay. So we'll move on to the next question. If Andy is younger than Samir, then Samir is 1 year older than Andy.
No, that's not true.
Can you give me a counter example?
Counter example.
Yes.
Um,
Counter example में give me an example among this only, so that the given condition holds true, but it is not saying the whole part of the statement. You give one counter example.
Andy is if Samir is like 2 years older than Andy.
Yes, good one. So it doesn't say that Andy is younger, does not means Samir is only 1 year. He can be 1 month elder to him.
Yeah.
He can be 10 years elder to him. So these are many counter examples. So this is not a condition. All right.
Yes, sir.
What about this? If m is less than equal to 10, then m is greater than 4.
If M is less than 10. No, that's not true.
M can be greater than 4. That is not a true. Okay. You can say only that m counter example you can give that m can be greater than 9 as well.
Yeah.
M can be greater than 1 as well. What about this?
No, it's not true.
Give me a counter example.
Of 45.
45 is a multiple of 9. It is not divisible by 3.
Wait. Oh, it is. It is. Wait, actually, wait.
Give me a counter example. Then only I will get to know.
I'm thinking. Yeah, 2. 2 times 9, 18, 18. No, wait. 18 is not divisible by 3.
Why? 3 into 6
Oh, it
is what?
is, because, oh God. Wait, so does that mean this is a true conditional?
It is a true condition because you know why? Because 3 divides 9 itself. See, a number which is already divisible by 3, if this number is dividing any other number, the factors of 9 will also divide that number. Okay, tell me how 10 is formed. 10 is formed by multiplying 2 into 5, right?
Yes, sir.
Now tell me, if a number is divided by 10, for sure, will it not be divided by 5 and 2? Because how that number is formed? You suppose any number which is a multiple of 10, how that number will be formed? Suppose let us say 130. It will formed by multiplying 13 into 10 only.
Yes, sir.
And how 10 is formed? 10 is formed by multiplying by 2 into 5 only. That means the number will be multiple of 2 and 5 both. Are you getting it?
Yes, sir.
If a number is divisible by 9, that means it is a multiple of 9. Of course, it is divisible by 3 because 3 itself is a factor of 9. 3 itself is a smaller number. How 9 is made? 9 is made by multiplying 3 into 3. So, if a number is multiplied by 9, of course, it will be divisible by 3 as well. So, this condition is true. Tell me the next one. If m and n are negative numbers, then the product of m and n is negative.
That's not true.
That
Wait,
is,
product.
you don't need a counter example. That condition itself is false.
Exactly.
Two negative numbers, if you multiply, it will become positive only.
Yeah.
If an integer is divisible by 10, then it is divisible, then its last digit is 0. What do you say?
No.
Then tell me a counter example.
Oh, wait, by 10.
Yes, by 10.
Then this is true.
So what should I click? Yes?
Yeah.
Okay.
But what about the okay.
If a number is a rational number, then the quotient is of two integers. What is the definition of a rational number?
Hmm.
You don't know?
Wait, I'm trying to think because I've always forgotten this definition of the types of numbers.
I told you there are two types of rational numbers. One was repeating and terminating.
Yeah.
And rational numbers is a number in which the numbers can be written in the form of p by q, where p and q are integers, but q is not equal to 0.
So
So
does
if a
that?
number is a rational, then its quotient of it is a quotient of two integers. So we can give a counter example. No, because we can't divide a number by 0. It quotient cannot be of two integers. 0 is an integer.
Hmm.
Okay, 0 is an
Yeah.
integer. Okay, no. They are saying if a number is a rational number, then it is a quotient of two integers. Yeah, that is correct. You take any rational number. Let it be any rational number. It will be having a quotient. It will be having a numerator and a denominator which are integers. That is true. That is true.
Yes.
Okay. Dividing by 0 is a different concept. Okay. Is the following condition true?
If W is greater, if W is less than 4, then W is less than or equal. No, because it can be less than or equal to 3 as well.
Wow. You have a counter example. Good one. Good one.
If J is, huh? Wait, this is giving me a stroke trying to understand what it's saying.
It is saying that, okay, then you know what? J is equal to 3 actually.
Yeah, that's what.
Okay, a number cannot be less than equal to 3 is greater than equal to 3. So that means this is incorrect statement. Okay, tell me for this.
No, because it can be also equal to 7.
Hmm?
No, because it can also be equal to 7.
Okay, it can also be 7.5. But you know what? If Z is less than 8, then Z is less than 7. You are saying no, Z can be equal to 7 as well, right?
Yeah.
Okay. But it is saying, okay, so Z is less than 8, Z is less than 7 can't be true, Z can equal to 7. Okay, good one. Good logic. Tell me this. If n is greater than equal to 4, then n is less than equal to 6.
No,
Okay.
that doesn't need any proof. It's just no.
Is the following condition true? If a number is divisible by 4, then it is divisible by 2.
Yes.
If r is less than 8, then r is greater than 2. No need for this. If a
Yeah.
shape is a square, then it has 4 sides.
Yeah.
Sure?
Yeah.
Okay. If two angles have the same measure, then they are congruent.
I forgot what congruent means.
Congruent means equal. They superimpose on each other.
Oh, okay. So if two, yeah, then that's true.
If p is greater than 8, then p is greater than 7.
P is greater than 8, and P is greater than or equal to. No, because it can also be greater than or equal to 8.
So what they are saying as well. Give me a counter example. A number which is greater than 7 but not greater than 8.
Great.
Which is not following this condition. Tell me a number which is greater than 8 but not following this condition.
So it's saying that P is greater than 8 and P is also greater or equal to 7, but that's false because P can also be equal to 8.
No, try to understand.
Wait.
The first rule is you cannot make it P equal to 8. First rule is you cannot make P equal to 8. You have to think of all the numbers in your life which are greater than 8. This is your first condition. This is the condition. Are you getting it?
Yeah.
The condition is you can't think of a number which is equal to 8. You have to think of the number which is always greater than 8. Now, among those numbers, tell me a number which does not follow this condition. A number which is greater than 8 but not greater than 7.
Sir, none.
None. That means this condition is true.
Ooh.
Are you getting it?
Yeah.
This condition is very true because a number which is greater than 8 will always be greater than 7 as well. 7 is less than 8. If the question was like this, greater than 9, then we can have a number 8.5 which is less than 9. It is not greater than 9, but the other number which they are giving is already less than 8. That means, what does it mean? It means that this condition is true for all the numbers. Are you getting it?
Yes, sir.
This is what I supposed to understand the logic. If Charlie has more marbles than Steven, then Steven has fewer marbles than Charlie. If Charlie has more marbles than Steven, then Steven has fewer marbles than Charlie. Tell me.
Yeah.
Okay, you are agreeing with this? You don't have any counter example?
No, I don't.
Because when Charlie is already having more, it is but obvious that Steven will have fewer. Okay. Is the following condition true? If a quadrilateral has all sides congruent, then it is a square.
Yeah.
Sure?
Yes.
Okay. Can I give a counter example?
Okay.
Tell me about rhombus.
Oh, I forgot about those.
You don't know what is a rhombus?
Yeah, I forgot that they existed also.
Okay. So rhombus has all the four sides equal. Okay?
Yeah.
And there is a square. In the square, all the sides are equal, but all the angles are also 90 degree. The only difference is the angle. So they are saying that if a quadrilateral has all the sides congruent, yeah, all the sides are congruent, then it is a square. No, not required. It can be rhombus as well.
Ooh, okay.
Okay?
Okay.
The answer is no. Tell me, if G is greater than 2, then if G is less than 2, then G is less than 5. What do you say about this?
Yeah.
Sure?
Yeah, it has to be less than 5.
If B is greater than 4, then B is greater than 9.
No.
Because, give me a counter example.
5.
Wow. Excellent day.
Wow.
Okay. W is less than 4, then W is less than equal to 8.
No.
Then give me a counter example.
7.
7 is not less than 4, my dear.
Yeah, but then it's saying that then W is less.
No.
Wait, it's saying that W is
First, first fill up the condition, my dear. You can't take 7 because the number you have to take should be less than 4.
Hmm.
So if W is less than 4, you think of any number in the world which is less than 4 and check it whether that number is less than 8 or not.
Oh, like that.
Yes, like that.
Okay, then that's true.
Then it's true. Alright?
Yes, sir.
You are not allowed to take 7. Why? Because it has to be less than 4. How can you take 7? You can't take 7. Are you getting it? The question is reversed. Suppose it says if W is less than equal to 8, then W is less than 4. Then you can take 7 as well. If you can take 7. But if is with W is less than 4, so you can't take 7. Are you getting it?
Yes, sir.
Let us take another number. Is the following conditional true? If a polyhedron has 6 faces, then it is a cube. Tell me.
If a polyhedron.
Polyhedron means any polygon. Means it is a closed figure made up of only straight lines. Any closed figure which have 6 faces. Polyhedron. Hedron means 3 dimension. Sorry, it is 3 dimension.
Yeah.
How many faces it has? 6 faces. You can see all the 6 faces. 1, 2, front and back, side, right side, left side, top and bottom. These are the 6 faces. Then they are saying it is a cube. It has 6 faces. It is a cube. Is it true? If a polyhedron has 6 faces, it is a cube. Is this statement true? Let me show you as well.
Yeah.
So, now this is a polyhedron.
Yeah.
This is another polyhedron. I am expanding this so that you can see all the 6 faces. Can you see that?
Yeah.
Here also I am doing the same thing. Now tell me, do you really think that both the polyhedrons are having 6 faces and they are cube? Is this statement true?
They both have 6 faces, but one of them is not a cube.
In fact, both of them are not cube.
Oh, yeah.
Until unless you have been mentioned that this side is equal to this side. It is not mentioned anywhere. You are just assuming it, okay? Until unless it is not given, you can't assume anything. So that means it can be a cuboid as well. It can be a cuboid as well.
Yeah.
Alright? Okay,
Right.
tell me, is the following condition true? Please try to understand the logic and then tell me your answer. If z is greater than or equal to 6, then z is greater than 2.
Yeah.
Okay, after a long time you said yes. Good one. If it is raining, then it is cloudy.
Yeah.
Sure, are you sure that only clouds brings the rain?
No, because in Dubai they have that artificial rain too. Okay, no.
No, we are not talking about artificial rain. We are talking about only natural rain. You tell me, if there is a natural rain,
Yeah.
Are you sure? Hi. Are you sure that it will be a cloudy?
It doesn't necessarily have to be cloudy.
It may happen. This is a very ambiguous question. I'm not sure.
Yeah,
I'm not sure whether it is a cloudy means that it will rain. It may be cloudy, it may not rain.
yeah,
Okay, but that is not they are saying. They are saying if it is raining, then the clouds are there. So, can we have a rain without in a clear sky? Is it possible that we can have a rain in a clear sky? I think if we go by the logic, there cannot be rain without the clouds. Clouds has to be
yeah.
there. So if it is raining, then we can say it is cloudy. I think it is yes. It may be a wrong. Let us check it out. Okay. Wow.
Oh my God.
Okay. Is the following conditional true? If the number is a square root of an integer, then it is irrational. Is it true? Is it true?
If the number is a square root of an integer. I'm not quite sure.
Square root of an integer, you take any square root. Let us say square root of 2. Let us say square root of 0. Let us say square root of 4. Let us say square root of 9. Let us say square root of 12. They are saying if a number is a square root of an integer, then it is irrational. Are you sure that all these numbers are irrationals?
No.
Because some of the numbers you can say they are rational as well.
Yeah.
So if you want to give a counter example, you can easily give them that under root 9. This is a square of a integer, but it is a rational number. This is 3 actually. Are you getting it?
Yeah.
Sure?
Yeah.
Okay. So I will mark it as no.
Oh, we did it.
Wow. So congratulations, you have mastered the skill and earned a gold medal. Okay. In 30 minutes we got a gold medal. So let us do with the A4 now. Okay, negations. Now what are negations? What is the negation in the following inequality? So they are saying minus z is less than minus 5. So what could be the negation? Negation is minus z is greater than minus 5. I think this will be the negation. You have to just opposite the statement. Negate it. Suppose I say I go to the school, so I say I don't go to the school.
Okay.
You have to reverse the process. Okay, so minus z is less than minus 5, so we'll say minus z is greater than minus 5.
Okay.
Are you getting it?
Yeah.
Let us see if this is right or wrong. Let us see if this is right or wrong. If it is wrong, then we will see the video.
Yeah.
Okay, so they are saying that okay, it is greater than or equal to. You have I missed that. It can be equal to as well because this is less than. So we have to take equal to as well. All right.
Right.
Did you get that?
Yeah.
Negation of this is this one. You can write this. Please write this definition. The negation of a statement is another statement that has the opposite meaning. It also has the opposite truth value. Please write down this.
Yes.
Is it visible?
Yeah.
Okay.
Done, sir.
Done.
Yeah.
U is greater than equal to 7. Tell me. What is the negation of this? Opposite.
Is U is less than equal to 7.
No, you can't say less than or equal to. Opposite. Equal to is already given.
Okay.
It is less than 7. Alright?
Okay.
You can use, see, if you join them together, you can be anywhere. Are you getting it? Negation means, okay, negation is like an empty space. In your house, you have some matter which takes the place of everywhere. Are you getting it?
Yeah.
But there is some empty spaces as well. So empty space plus matter together make the surroundings. So you have to make the surroundings. So in the surrounding, you have already said that U is greater than equal to 7. So what is the empty space now? The empty space is U is less than 7 because that numbers are left over now. Okay, you have to say the opposite statement. Are you getting it?
Yeah.
Sure.
Yeah.
Brilliant. V is greater than 5. Now you can be a more quick.
V is less than 5.
Wonderful. See, once you understand the concept, it is so easy. Tell me for this.
Yeah. Wait.
Tell me before I click. Okay, oh, it's my bad.
I was gonna say, but then you clicked.
Oh, my bad. So I will just cover it up. Okay, I will cover it up
Okay,
with 3
cover it.
questions. So this could be minus B is greater than 6.
B is
This one.
no.
Yeah. So
Really?
G is less than or equal to 1.
Hmm.
So X is greater than 6.
The first
So,
option.
so this will be minus W is less than minus 2. So I have covered up all the 4 questions. Now it's your time now. Now you tell me.
The first option, sir.
The first option?
Yeah.
Okay. What about this one?
Sir, the second option.
Okay. This one?
First option.
Okay. This one?
Last option.
Last option?
No, wait. No. Second option.
Wow. Now you're getting it.
Mm-hmm. First option.
First
No,
option?
sorry, last option.
Last option?
Yeah. First option.
Okay. See, it will say about your mind. Excellent.
Mm-hmm.
Okay. Minus 3 is less than minus 10.
Second option.
Second option?
Yeah.
Terrific. Mind.
Second option.
Okay.
First option.
This one?
Yep. Oh, nice.
Wow. 5 minutes. Well done. So one more gold medal is with us. Now I want you to share your screen if it is possible for you. And please see the video of the question number 5. Converses, inverses and contrapositives. I want you to see with you. Because in my screen, if I will use the video, the sound will not be heard. So I want you to share the screen. And when you share the screen, click on the sound icon so that we all can hear what it is being said. Alright?
Right, sir.
Okay.
Sir, is my screen visible?
Yeah, visible, my dear. I want you to open A5.
A5.
Converses, inverses, and open the video.
Oh,
No, wait.
I don't think there is a video.
No,
Oh,
there
here.
will be. Video is there first.
Today, we're going to learn about converses, inverses, and contrapositives of conditional statements. Let's get started. A conditional statement is written in the form if A, then B. We call A the hypothesis and B the conclusion. Say we have the conditional, if Ronald has an umbrella, then it is raining. Our hypothesis is Ronald has an umbrella. Our conclusion is it is raining. We can also write different versions of our conditional. The converse of a conditional statement switches the hypothesis and conclusion. So our converse is, if it is raining, then Ronald has an umbrella. We can also write the inverse, which negates both the hypothesis and the conclusion. So the inverse of this statement is, if Ronald does not have an umbrella, then it is not raining. Finally, we have the contrapositive, which switches the hypothesis and conclusion of the original conditional and negates both of them. So here, the contrapositive is, if it is not raining, then Ronald does not have an umbrella.
Please wait.
The statements, if Ronald has an umbrella, then it is
Pause.
raining.
I have to take the snapshot of this
Yes, sir.
so that we can write it. I want you to write it. Write all the statements in your
Okay.
in your notebook.
Yeah, right.
So contrapositive is the inverse of, you can say, converse,
Yeah.
and inverse is the inverse of the original statement.
Yeah.
Are you getting it?
Yeah.
Contrapositive is the inverse of converse.
Hmm.
You can start playing the video.
Okay, so just 2 minutes.
It's a beautiful thing that I am also learning with you.
Mhm.
Really, these things are not being taught anywhere. these applies to logic and
Yeah.
reasoning in mathematics. So these topics are abandoned by the teachers. They think it is useless, but it is very useful.
It is.
Yes. I have taken the snapshot as well.
Okay.
Okay, you can continue the video.
Yeah.
And if it is not raining, then Ronald does not have an umbrella are actually equivalent. In fact, any statement and its contrapositive are always equivalent. Now let's work through a few examples. In our first example, we have to find the converse of the conditional. If Aaron drinks water, then she is thirsty. Our hypothesis is Aaron drinks water. Our conclusion is she is thirsty. The converse switches the hypothesis and conclusion. So our new statement is if Aaron is thirsty, then she drinks water. Let's do another one. In this problem, we have two statements, and we want to know if the second is a contrapositive, converse, or inverse of the first. Let's see. The hypothesis in the first statement is Harry is not very hungry, and the conclusion is he is going to eat a small portion of potatoes. In the second conditional, the hypothesis is Harry is going to eat a small portion of potatoes, and the conclusion is he is not very hungry. What changed from the first conditional to the second? We can see that the hypothesis and conclusion have been switched. This means that the second conditional is the converse of the first. Let's take a look at the next example. In this example, we have two statements. Is the second conditional the contrapositive, converse, or inverse of the first conditional? The hypothesis in the first statement is Richard is going to eat cashews, and the conclusion is it is not Monday. In the second conditional, the hypothesis is Richard is not going to eat cashews, and the conclusion is it is Monday. We can see that the second conditional negates the hypothesis of the first. But what about the conclusions? We went from it is not Monday to it is Monday. Well, to negate it is not Monday, we want the opposite of this statement, which is it is Monday. So we also negated the conclusion here. Since we negated both the hypothesis and the conclusion, this is the inverse of the first conditional. Let's take a look at our final example. We have the conditional, if g is greater than or equal to 7, then g is less than or equal to 9. Is the contrapositive of this conditional true? Well, we're used to seeing our conditionals written as sentences, so let's do that here. Our hypothesis is g is greater than or equal to 7, and our conclusion is g is less than or equal to 9. We want to figure out if the contrapositive of this statement is true, so let's find the contrapositive. We'll switch the hypothesis and conclusion and negate both. So our new statement is, if g is not less than or equal to 9, then g is not greater than or equal to 7. Let's simplify this a bit by writing it with math symbols again. G is not less than or equal to 9 means that g is greater than 9. And g is not greater than or equal to 7 means that g is less than 7. Great! Now that we have our conditional, is it true? Well, if g is greater than 9, is it less than 7? No. So let's find a counterexample to show that this is false. Recall that a counterexample satisfies our hypothesis but not our conclusion. If we let g be 10, this satisfies our hypothesis because 10 is greater than 9, but it does not satisfy our conclusion since 10 is not less than 7. So we found a counterexample, which means the contrapositive is not true. This makes sense because we learned that a statement and its contrapositive are always equivalent. And here, our original statement was false as well, since there are many numbers greater than 7 that are also greater than 9. Great job! Now you're ready to work with these statements on your own.
You understood some part?
Yeah, mostly.
Let us try to figure it out.
Yeah.
So now I'm opening the sheet.
Okay.
Converse, inverse, okay. What is the contrapositive of the following condition? If Haley's dog ate the style section, then she is not reading the newspaper. Contrapositive. Let us check it again. what is a contrapositive? Contrapositive is the negation of the counter of the first statement. Okay, see, it is a negation. So first you have to switch and then you have to negate. For contrapositive, you have to switch and you have to negate. Let us see if we can switch and negate together. So if we switch, then we will say that she is not reading the newspaper means she is reading the newspaper. Okay, so we will see where the hell is reading the newspaper. So here she is reading, here she is not reading. So this is the only option that we will get. Are you getting it?
Yes, sir.
Okay, as per my logic, I see this. Okay, well done. Good start. Let us go with the next question. What is the converse of the following condition? If Erin is not thirsty, then she is not going to drink the grape juice. Now, what is the converse of a statement? Converse means it is just a switch. Converse means it is just a switch. If you switch this statement, it will become if Erin is not going to drink the grape juice. If Erin is not going to give the grape juice. So this is the only statement we are having now. Are you getting it?
Yes, sir.
Can you do it now?
Okay, I'll try.
Okay, so this is the question. Just see contrapositive. See the statement and let us see what is a contrapositive. What are the two things that you do in the contrapositive? Tell me. One, you can say a switch
Switch and negate.
and negate. So please switch and negate and see. Tell me which option is correct.
The first one.
First one. Okay. Wonderful. You understood? Easy now.
Yeah.
Okay. What is the
First
contrapositive
one.
of the following condition? Contrapositive, you know what
First
is
one.
first one?
Yes.
Switch and negated. Okay. So negation of negation is positive. Okay. What about this one?
First one.
If it is sunny outside, then Kenny is wearing a hat. So you need to say converse. Means you have to just switch. Okay. What about this one? If a Huskies game will not be on television, then Victoria will buy tickets for it. You have to tell me if a Huskies game will be on television. Okay. Now they have just negated it.
Yeah.
So negation is what?
Inverse.
Inverse. Okay. So this statement is inverse. Good one, dear. You have a great mind. Okay. Tell me for this one.
Sir, it's a contrapositive.
It's a contrapositive. You can see a switch and a negation. Okay, good. Tell me for this one. If Mark is at farmers, okay, you just check it out. What is happening? So I think it is a
Contrapositive.
Yes. Now we have more faster. Okay. Tell me for this.
Inverse.
Inverse negation is inverse.
Yep.
Inverse.
Inverse.
Let us say who tells first. Okay.
Huh? Okay.
Okay. Oh.
Oh. Oh, come on.
This
Okay,
is
forget it then.
First of all, we have to change this into the statement. Okay. First of all, let us try to change the statement into the statement. Okay. What is the statement for this? Tell me.
If V is greater or equal to 5.
Okay. No, if V is
Oh, less than.
less than or equal to 5, then V is greater than equal to 5. First of all, this statement is not true. Now, what is the converse of this? What do you do in the converse? Just switch. What we do in the converse? We just switch.
Which?
Switch means we will say if V is greater than or equal to 5, then V is less than or equal to 5. I think that doesn't make any sense.
That does not make sense.
So I hope that it is no. They're saying is the converse of the statement is true. The answer is no. Let us check it out. Okay. Brilliant. What about this? So let us change this. Inverse. Inverse means you have to negate it, right? Negation means you have to say Z is less than 8. No. Negation means if Z is, negation means you will say less than 1, then Z is less than 8. Is this true?
If Z is greater than 1, then Z.
No, I have negated it. See, I have done the negation. Negation means the other part of it.
Okay.
Inverse means negation, right?
Yeah.
So I have done the negation. Tell me, is the negation true? Any number you think which is less than 1 is also less than 8.
Yeah.
Sure?
Yeah.
With my logic, if I go, I am checking it as yes. What about you?
Yeah.
Yes?
Yeah.
That's right.
Okay, good.
Now again inverse. Inverse means you have to negate the statement. Negation means you have to say the other part of it. So if u is greater than 9, negation means u is less than equal to 9. Alright?
Yeah.
What is the negation of this? U is greater than 10. Negation means the other part, other side.
Yeah.
Okay, it's covering the whole environment. The empty space. Empty space is u is greater than 10. Now tell me, if this follows, is it true? No.
No.
In fact, 9 itself is not greater than 10.
Exactly.
So this is not true. Wow. Is the inverse of, first of all, you have to tell me the inverse of this statement. Tell me inverse. What should I write? Tell me the inverse of the first one.
So that means P is greater than 10.
Wonderful. Then
P is greater than 9.
what do you say about this? Is this making any sense?
Yeah, that makes sense.
So let us mark it yes. Contrapositive. So contrapositive means what you have to do? Two things. You have to switch, you have to negate. You
Yeah.
have to switch, you have to negate. So let us switch. So if we switch, we will put this here. So if V is, now negate this. I want you to negate this.
So V is greater than 6.
Then negate this.
V is greater than 6.
No.
Greater than equal to 6.
Is this true? Yeah, that's making
Yeah, I
sense.
mean,
It's
yeah.
making sense, right?
it makes sense.
Okay. Excellente.
Mhm.
Okay. Inverse. Inverse means what do you need to do?
Just
Just
switch.
negate it.
Yeah.
So how you will negate?
J is greater than 7.
Okay.
Then J is greater than 1.
Okay. Is this true?
No.
Why? Then tell me a counter example.
3.
3. 3. You can't take 3, my dear.
How?
Because
Because
J
it has
has
to
to
be
be
greater than 7.
The first
Wait.
condition is not fulfilled. You can't take 3. Tell me. A number which is greater
Okay,
than
never
7 but
mind.
not greater than
Then
1.
this is true. Then this is true. It
This
has
is
to. If
true?
it's greater than 7, it's greater than 1.
Okay, so grandmother is always greater than granddaughter. Right? Grandmother is greater than mother. Mother is greater than granddaughter. So grandmother is always elder to granddaughter. Okay, next question.
Contrapositive. So
Contrapositive, you have to do two things. You have to
Switch and
switch
negate.
and negate. Then W is Tell me, is it true?
If so, W is less than 3, then W is. Yeah, that's true.
No, no. I can give you a counter example.
Really?
Yes.
Oh, then give it.
3. Wait. I can't take 3. Okay, my bad. I can't take 3. Okay, it has to be less than 3. But the counter example is W can be 3. See, if I take 2, let us say 2. 2 is less than W, right? But here it is saying that W is equal to 3. And W is less than equal to 3. Okay. I am having one doubt here. The doubt is that if we are taking W is less than 3, is it less than 3? Yeah, the number which is less than 3 is less than or equal to 3. Yeah, this is true. I can't make any counter example.
Yeah, see?
I'm sorry. Okay.
It's okay, sir.
Let's do this one. I want you to do the converse. You know what is a converse?
Yeah, switch.
Switch.
So T is less than 5, then T is Wait.
Yeah. If T is
If
less
T
than
is less
5,
than 5,
then T is greater than
No.
how can it be? झूठ
No.
बोलता है, बार बार झूठ बोलो. Oh my god.
Oh wow.
And you know what is the timing? Exact at the end
Wow.
of the class.
We did so well.
And we are extraordinary as well.
This is awesome.
Wonderful, my dear. Well done today. Really very happy. I think
Thank
you and me, both of us learned 3 things today.
Yeah.
One was condition, negations, and this part, converse, inverse, and contrapositive,
So
right?
6 things.
Yeah, 6 things. So biconditional truth tables and truth values we can do in the next class. Until you can tell me any topic which you want to learn from me.
Yes.
Till then, bye. Take care.
Bye, sir. Thank you, sir.
Bye, beta.
Bye.